To start this lesson, I'd like you to take yourself back into the mind of an Algebra 1 student. So the only math that you know is what you learned in Algebra 1. So think back to being a freshman in high school, new onto the Helix campus, or maybe even an 8th grader still in middle school. All you know is what an Algebra 1 student knows. And we're going to take a look at these different equations. We're going to move the variable around to different spots in the equation. So first, if we had the variable in the base, we'll think about if an Algebra 1 student could solve that. Hopefully they could. Square root both sides. Hopefully remember the plus or minus. We can figure out x is plus or minus square root of 10. Not too bad. And then here, if both the base and the exponent are a number, well, that's just simple. 10 times 10, 100 is x. Not really any solving to do there too much. But then how about this third one here? If you're an Algebra 1 student and the base is a number and the variable is an exponent, the exponent is a variable, well, an Algebra 1 student would have no idea how to solve that, right? And that's the situation that mathematicians were in at some point in mathematical history, is they wanted to solve an equation where the exponent was an unknown. They knew the base, they knew the answer, but they didn't know what the exponent was. So how were they going to do that? Well, of course, what they did was they invented logarithms. Okay, so a logarithm, we just do log for log. I do it in cursive, otherwise people ask me what's 1 og or 10g. So we do log, and then, well, the whole point of the logarithm was to find the exponent. So that means logs are always going to equal the exponent. That's an important thing to remember. The log will always equal the exponent, because that's the whole purpose of the logarithm, is to find an exponent. Okay. Well, then the logarithm, you've got a couple different things. You have to look at the base. And so we put the base as kind of a little small number, a subscript on the logarithm there. And then the other number goes here. Okay. So this is read as log base 2 of 10 equals x. And so that's how we can find that unknown exponent then. We can find log base 2 of 10. A logarithm is a function that can find those different unknown exponents for us. So we can use our calculator here. And so what you can do, you can actually just press alpha window. If you press alpha window, this fifth choice right here, log base, will allow you to type in any logs you want. So alpha window, and then the fifth choice, so just hit 5 or scroll down to log base, and then you can just type it in exactly as it looks, log base 2 of 10. All right, and so that means that that unknown exponent was 3.322 approximately. Now you can check it. You can say 2 to that power. You can do second negative. Not sure if you know about this, but right above negative, ants. If I do second negative to get to ants, that's that exact answer, because of course that's around a decimal. 2 to that ants, there we go, is 10. All right, 2 to this number here, whoops, 2 to that number right there gives us 10. Okay. If alpha window didn't do anything for you, you have to use what's called the change of base formula. This would be the same thing as log 10 over log 2. And so you can do alpha y equals. The buttons right here, this log is, we'll talk about this in a second here, that's base 10 log. You'd have to say log of 10 over log of 2, just for anybody who isn't able to type them in nicely as we did right here. Okay, so this is logarithms for finding unknown exponents. So it is very important to know how to switch back and forth between exponential form and log form. So the biggest thing, though, is just to remember what I just said, that logs are exponents. Okay? Logs are exponents. That's why we came up with logarithms, was to find exponents. So the log will always equal the exponent. Okay, so if you remember that logs are exponents, the other thing you have to do is remember what the base is. Okay, so we talked about this in the previous section here. The thing that has an exponent on it is called the base. So what the exponent is on, it's called the base. Well, then if you just remember how logs are read, that we read this log base 2 of 10, you remember that this little number down here is the base. So if you know the base is the base and the log equals the exponent, well, then the answer or the other number will just kind of fall into place. Okay, there are a couple of special types of logs. Hopefully, remember sometimes there's a log where we don't write the base. It's called a common logarithm. If we don't write the base, it's a base 10. So those are pretty common. There's also a natural logarithm. Log base e, that number about 2.7 e. If we have a log base e, it's called natural log. The reason is for calculus reasons. Logs base e work really well for calculus. Other logarithms don't work quite as nicely in calculus. So in calculus, you're going to work with natural logs a whole lot. I have had students sometimes who just like natural logs really bother them somehow. They really don't like natural logs. If you're one of those students, just every time you see ln, just rewrite it as log base e, and then just work with it from there. Just make sure in your final answers on a test, never write log base e. And for final answers on a test, I always need to see natural log, not log base e. Okay. All right, so if we want to change forms here, let's say now that we were starting with the log, and we want to switch it to exponential, okay? Remember, this is log base f, so the f is the base, and then logs are exponents, so the h has to be the exponent, and that means that the g has to be the answer, has to be what it equals. Okay, so why don't you take just a couple seconds, go ahead and change forms on numbers 2 and 3 right here. Just do 2 and 3 real quick. Make sure you know how to switch things back and forth. Right, and so those should have been your answers. Just make sure you know that the base is the base and the log equals the exponent. It should be fine. Okay. All right, so now let's try to evaluate some of these logarithms, see what they equal. So remember, a log is an exponent, so we're trying to find the exponent. So we want the exponent that we would put on 2 to get 32. Okay, so we would need to kind of count up. We would need to think, kind of count on your fingers as you're thinking this: 2, 4, 8, 16, 32. And it should be at 5 fingers right now, so that's 2 to the 5th. Okay. And so this is one of the few times where actually not showing work I think is preferable, because I think it shows that you really understand logs. If you can just get that answer without showing any work at all, that's great. Just give the answer, you're good to go. Now, if it's harder for you to just stare at it and say that, the trick is to always put it equal to x. So let's say that we didn't know this yet. If we had this equal to x, well, then you can change forms. You can say, all right, 2 is the base, and then logs are exponents, so the x is the exponent, and then you would be able to see what we were just talking about, that we're looking for 2 to the what is 32. What exponent we put on 2 to get 32. Okay. All right, so similarly here, if you can get the answer just by looking at it, that's great. If you need to, you can put this equal to x, and then change forms so that you can actually see the question of 4 to the what is 2. Okay. And then that one, well, you might need a little bit more work to figure it out, or you might be able to think about it and just kind of see it. So we want an exponent that's going to make it smaller. So remember, a couple of sections ago, we learned that fractional exponents are roots. So we could have a fraction exponent that's a root that makes this smaller. And well, the square root of 4 is 2. So if we're thinking that, if we're thinking that the square root of 4 is 2, well, remember that 4 to the 1/2, that's the square root of 4. And so that means this answer right here is going to be a half. Okay? If we put a half as an exponent, that's a square root. Okay, or there's that trick where we can have them be the same base on both sides. We can call this 2 squared to the x, and then call this 2 to the first. So we've got 2 to the 2x equals 2 to the first. Remember, power to power, we multiply. So 2x equals 1, so x is a half. Okay, so those are some ways, if you don't see it right away, that you could do some work and get there. But again, it's actually even preferable if you don't write any of that down. If you're able to just look at that and see that that's a half, then that's perfect. That's great. Okay. All right, how about natural log of 1? All right, so it's a log, so we're trying to find an exponent. So we're going to find the exponent that we put on, well, we don't see the base. Remember what the base is when it's ln, the base is e. So we want the exponent that we put on e to get 1. Well, it actually doesn't matter what the base is, right? The exponent you use to get 1, regardless of the base, is 0. Right? Again, if you needed some work here, you could call that equal to x, and you could rewrite that as log base e. So you could say x equals log base e of 1. Notice that if you're rewriting that as log base e, don't move anything around. Okay, if you're just rewriting as log base e, you're not changing forms. You don't get to move things around. Keep everything else exactly as it is, and just switch that around. And so then you'd have e to the x equals 1, and the exponent of 0 gives us 1. Okay. All right, what about here? What exponent could I put on e to get e? Well, the exponent that doesn't change anything is 1. Okay. Again, if you need to, you could go through the same process here. You'd be looking at e to the x equals e. Well, e to the 1 equals e. Okay. All right, well, how about this one down here, number 5? This one, I don't see the base right there. Remember what the base is if you don't see it. It's called a common logarithm. It's base 10. So I want 10 to what power is 1 over 100. Well, if I'm going to get a fraction, if it's going to be 1 over, I know the exponent has to be a negative number. All right, to get that 1 over, negative exponents make fractions. Well, then 100, well, what kind of exponent do I put on 10 to get 100? 10 squared is 100. I want negative 2. Okay. Again, if you needed to see this a little bit more, we're thinking 10 to the x is 1 over 100 is what we're looking for here. Fraction means negative, and then 2 zeros means the exponent's 2. Okay. Now, what about here, though? Natural log of 7. I want an exponent that I put on e to get 7. That's not going to be nice. You're going to need a calculator for that. Right? So just know that some of these could be no calculator problems if they're very specially made, but certainly there's a lot of problems where you would need a calculator, because that's the whole point of logarithms. The whole point of logarithms is to find unknown exponents, exponents that would be hard to find otherwise. Okay, so we could use this ln button. There's 2 logs built into your calculator over here. So you can use the ln button for this, ln of 7, and find that that's 1.946 approximately. Okay. And so we're just using calculator on this one. Okay. Now just make sure you understand what you just found. You found a logarithm, so you found an exponent. You found the exponent that you would put on e. There's actually a way to get e to the in your calculator. If you do second ln, they'll give you e to the, and you could do that answer, 1.9459, and so on, e to that answer. If I do e to that answer, what I'm going to get is 7. I was finding the exponent that I put on e to get 7. Okay. All right, similarly on this one here, if you're trying to find an exponent that you put on 4 to get 3, well, that's kind of tough. That's not anything that anybody's going to just know off the top of their head. There's no nice exponent for that, so we need a calculator. And the way that most of us can do this easily is alpha window, and then that 5th choice, alpha window, hit 5. We want log base 4 of 3. Okay. And so that's my answer, and that means if I do 4 to that number, what am I going to get? I'm going to get 3. Okay? I found the exponent that when I put it on 4, it gives me 3. All right. So the answer is about 0.792 using the calculator. Okay? And again, for anybody that alpha window doesn't work for you, if alpha window doesn't work for you, then what you have to do is log 3 divided by log 4. Notice the 4 is written a little bit lower, and so the 4 would go on the bottom there. That's another way to find it. Okay. Now, what about this one? You might think that's another one you would need a calculator on. I mean, 4 to what power is 32? 4 is usually just 4, 16, 64, 256. How are you going to get 32 out of that? Well, there actually is a decent exponent that we can figure out without a calculator. So one way to do it is you could think kind of back to roots and powers, back to the fractional exponents. And you could see, all right, well, I don't know how to make 4 turn into 32. I do know how to make 2 turn into 32, though. Well, what if I square root 4 first? Square root of 4 is 2, and then 2 to the 5th power is 32. So 2. So what I've got right here, what power of 4 do I have? Remember that square root is over 2, and then the 5th power is the 5. So what I'm looking for is 4 to the 5 halves, and that should give me the 32. So that means the answer here has to be 5 halves. I want to square root it and then raise it to the 5th power. So that's one way you could do it, is you could think through that process. Or you can go back to setting it equal to x. We're looking for the x equals 32. Let's use that trick of making both sides of the equation have the same base. Let's call this 2 squared to the x, and this is 2 to the 5th. Okay, so we get 2 to the 2x equals 2 to the 5th, which means that 2x has to equal 5, which is going to give us that 5 halves there. All right, so some of these you might need to write out and do some of that algebraic, make both sides have the same base work, or you can try to think about roots and powers. Okay. All right, so I've got a few for you to try now. So why don't you go ahead and try numbers 9 through 13 there. Those should all be ones that you would do without a calculator. 9 through 13, figure out those logs without a calculator. So you can check your answer on those. Most of those should have been pretty straightforward against one or two that maybe you would might to set it equal to x, change forms, and do that, make both sides in terms of the same base trick and solve it that way. Right. So now, what about this next set of problems here? What about if we combine an exponential and a logarithmic function? Okay, so we've got an exponent that is a log. Well, that should seem a little funny because we said that exponents were logs. So, okay, let's try to think about this here. Let me think about this log for just a second. So log base 5 of 27. So logs are exponents. Okay, so this right here is an exponent. Well, what exponent is it? It's the exponent that when I put it on 5, I get 27. This exponent right here is the exponent that when I put it on 5, I get 27. So let's take the exponent that when I put it on 5, I get 27, and let's put it on 5. Well, I'm going to get 27. It's kind of a silly question. Okay? Take the exponent. This is the exponent. When you put it on 5, you get 27. Put it on 5, well, you get 27. Okay, it's kind of silly. You could also see this as this is a function and it's inverse. Exponential and logarithmic functions are inverses. We're going to look at that a little bit more coming up in a couple sections. And if you remember, so it's kind of like square rooting and squaring, cancel each other out. You might remember if you do f of the inverse, you're supposed to get x, or the inverse of f, you're supposed to get x. Just like square root and square root will cancel each other out. The exponential and the log cancel each other out here. You get 27. Okay, so a lot of these, it's great if you can just kind of see that these are silly questions, just see it. But again, you could always show some work here. Okay, so you could set this equal to x. Now you might be a little unclear about how to change forms. If you think you could already, you could do it right away. Otherwise, something that could be helpful is to replace this whole thing with just maybe a U to help you see the overall structure here. So this is 5 to the something. Okay, just call it U. Let's call that whole log thing there U. Okay. Well, now let's change form. So this right now you can see that the main thing is exponential. So that means we have to change it to log. Okay, even though there was a log in the beginning, that's not the main thing. The main thing is the exponential structure. So then we'll switch it to log. Okay, logs are exponents. The log is going to equal the exponent. It's going to equal u. Log base, well, the base is 5. Okay, and so then that means the x has to go here. Okay, well then let's go ahead and put u back in now. Let's fill back in what u was. U was log base 5 of 27. Well, look at that. We've got log base 5 on both sides. This one's got x. This one's got 27. That means x has to be 27. There we go. Okay. All right, this one's going to be another silly question. Natural log, that's an exponent that goes on e. So this is the exponent. Then when I put it on e, I get 44. So take the exponent that when you put it on e and you get 44, well, put it on e and you're going to get 54. It's a silly question. Okay. If you don't see that, set that equal to x, and then call this u. So then you can change forms. You can have log base e. Logs are exponents. So then the x has to go there. Well, log base e, we should write that natural log. And let's fill u back in. U was that right there. And there you go. You can see natural log, x, 54. X has to be the 54. Okay. All right. So let's think about this one now. This one looks a little bit different. We still have the two things put together, but it looks a little bit different. Okay. So now we're trying to find the log. So we're trying to find an exponent. Okay. We're going to try to find an exponent. Well, this is the exponent that when I put it on, remember the base here is e. Okay. This is a log base e right here that you're looking for. Okay. So I'm trying to find the exponent that I could put on e to get e to the 13th. I'm trying to find the exponent that when I put it on e, it gives me e to the 13th. Well, what exponent could you put on e to get e to the 13th? 13. It's a silly question. The exponent is right there. What exponent do you put on e to get e to the 13th? Put 13 on e to get e to the 13th. Silly question. Okay. But if you don't see it, set it equal to x. So you've got x equals this natural log. We can call it log base e. And then again, you've got kind of more here than you're used to. You're just having one thing inside the log. So maybe call this u. Okay. You got natural log of something. Log base e of something. So you can change forms. You've got base e. Logs are exponents. So that's the exponent. It equals u. We'll fill your u back in. You've got e to the x equals e to the 13th. So e and e, x and 13. So x has to be 13. Okay. All right. So on a lot of these, they're just kind of silly questions. Things cancel out. The log and the exponential cancel out. But don't let us trick you here. Okay. So this log is an exponent that when you put it on 3, you get 9. But I'm not putting it on 3, I'm putting it on 9. So this is not a silly question. Okay. We can't just say this cancels out. They don't just cancel out here. It's not a silly question. It's just a two-step question. Take a look at this first. If I asked you log base 3 of 9, hopefully you would know that. Log base 3 of 9, again, if you needed to write it out, you could. Log base 3 of 9 means 3 to the what is 9. You could set that equal to x if you needed to. So 3 to the what is 9? Well, that's 2. So that means log base 3 of 9 is 2. So what I'm looking for here is 9 squared? Well, 9 squared, we can figure that out. That's 81. Okay, so just don't let us trick you here. Some of these are going to be silly questions where the log and the exponential cancel each other out. Some of them are just going to be two-step questions, okay, where you're just going to find one part of the problem first and then find the rest of the problem. Okay. All right, so why don't you try a few of these here. Go ahead and try these last 5 problems and just make sure you're sure about if it's a silly question or not, or if it's a two-step problem. Go ahead and try these last 5 problems without a calculator. So there are the answers that you can check. Most of those were silly questions except for the last one. Okay. So again, you could do the algebra on all of these if you wanted to. Um, but most of those first 4 were silly questions. So again, if you can just see the answer without that's why I use separate colors here. Really all you need is what's in blue. Okay? If you can just write what's in blue without doing any of the work in red, that's fantastic. Okay? If you don't see what's in blue right off the bat, then you can do some of that work in red to help yourself figure it out. Okay. Notice on 19, if you're setting it equal to something, we already used x. So probably set it equal to y or some other letter that hasn't been used instead of setting equal to x like all the other ones. And then 22 was not a silly question. We just figured out that 8 squared was 64, and then we did log base 2 of 64.